Testing 1, 2, 3. All right, we're lit. Listen, I've got a lot of fucking energy right now. A lot of fucking energy. Just hit the gym. It's been a month. It's been, you know how lockdown has been. So I've got hella energy to be stressed. Looking at binary tree questions right now. We won't even lie to you. We're gonna see how quickly it takes us to do two easy binary tree questions. And then if it takes us not too long, then we move on to a third. But I'll keep the recording within let's say 30 minutes per question, right? So a 90-minute recording max. So I want to go to things I've already solved, like I said, because these questions are questions that are pretty good to understand for understanding BFS, DFS, binary tree stuff. The ones I've already solved, but I didn't spend the time to kind of pay attention to the topics. Why is it not coming up? Oh, hang on. Oops, not binary search. I actually, after this, to be honest, I gotta look at linked list. Like, I realized that that's one of the things I pretty much never looked at. Linked lists. But anyway, binary search tree questions. Binary search, new. What? Where is me? Oh, tree. There we go. I was looking at binary search. All right, so yeah, these are solid questions. Did I do these in any medium questions? Post order, in order, traversal. Why would these be mediums? You should know how to do this before you even do the rest. It makes no sense. All right. What's this? Range sum, same tree, symmetric tree. All right. Let's try range sum of BST. Range sum of BST. All right. Okay. So what was this again? This was given the root node of a... Wait, didn't I do this? Wait, when's the last time I submitted this? I swear... Oh, I only did this once. 5th of October, as you can see. Don't absolutely... I'm not gonna remember what I did at all. Alright, hang on. Given the root node of a binary search tree, return the sum of values of all nodes with a value in the range low high. Alright, so we got okay, so from 7 to 15. 7 to 15, so what? 7 plus 5, 13, 13 plus 23, 23 plus 15, 32. So 32. Alright, so it's basically when you go low, you go to, okay, so then what's the second example? Just to make sure. 6, 10. Okay, without looking, okay, I already looked at it. Okay, 6 to 10. So what? 6 plus 7. Okay, wait, is it? But what if 10? Wait, low has to be less than high. Okay, yeah, okay, I was wondering. Because if the high was less than, I was like, how will that fucking find it? Okay, so wait, so 6, sorry, 6 plus 7. So, what was it? 18, we add with the 5, and then 18 plus, wait, what? Oh my God. I swear to God. I just added these numbers wrong, bro. Obviously, 6 plus 7, yeah, is 13. And 13 plus, wait. Oh, sorry, didn't add the 5. 13 plus 10. Okay, that makes sense. So let me try to understand this intuitively. So let's open up auto draw, right? Let's open up the old auto draw. See what we got here. So basically, right, we have a tree. Let's just get a simple tree here. Can I copy this image? Does it let me copy this image? Oops. Does it let me copy this image? Let me see. Can I paste an image here? Okay, it doesn't let me paste images. All right, so we'll draw it out. We will draw this out. Okay, so we got 10, 5, 3, oh Jesus Christ, 7, 15, and 18. All right. So we got this here. Let me just kind of make this fit better. Why did I make this so big? God damn it. Let me shrink this. All right. Okay. So basically, right? Basically, okay, cool. So the low here is 7 and the high was 15, right? 15. The high was 15. So we know that we have to essentially find 7. So we have to find where low is, right? And low would have to be on the left subtree, right? Because if it's on the right, how would that work? Or would that work? Would that work? I mean, if 7... Interesting. Is that like a case here? Hang on. What's the rules? Saying that low... Well, this is a binary search... Is this a binary search tree? This is a binary search tree? Alright, if it's a binary search tree, then it's impossible for high to be on the left subtree, because that's not how binary search trees are. You can't, otherwise you get O in complexity. So we know that 15, we know that the bigger number will always be on the right? And we know the smaller will always be on the left, so it's not to worry about that. So basically you need to just find 7. We need to recursively find 7, return the value, and then make our way back up, and then through the nodes ask ourselves, is that value less than 15, the high, and greater than the low, or greater than or equal to the low, right? And then we add it and add it and add it. So we do 7 plus, oh wait, is it 7? That's the 7, 15. So we do 7 plus 10 is 17, plus 15 is 32, okay? I realized at the start I said that 7 plus 5 plus 10 is 15 is 32. Yeah, it's not 32. It's not 32. Listen. Don't come at me because I don't know what the fuck I'm saying, man. I don't even know what the fuck I was saying. Hang on. So we can see that we find 7. Listen, okay, here's the thing, right? Intuitively, I fully understand binary trees. It makes sense to me. I can just look at it in my head and say, oh, look, there's the answer. Cool. I understand how they work perfectly. But then you start fucking involving recursion and it pisses me off. But you know, this is the thing. You just gotta face the challenges. You know how it is. We look, so hang on. I know that, okay, so we recursively find 7. Right? I.e., the thing is though, it's not that 7 has to be a null node. Sorry, a leaf node. It doesn't have to be a leaf node, or does it? Given the root node of a binary search tree. Okay. Given the root node of a binary search tree, return the sum. Wait, what? Given the root node of a binary search tree, return the sum of values of all. Okay. So it doesn't have to be a leaf node. 7 doesn't have to be a leaf node. Like 7 could have been up here, right? And then we could have just added these 2 numbers. So the point is we go down until we find 7, then return. So I can imagine the recursion would be something like, all right, so am I missing something here? Is something missing here? Hang on. Oh yeah. Okay. So I can imagine, yeah, that we have, of course, the usual. If not root, return. Obviously, if nothing's there, just return. Just return. Essentially, we don't want anything. Well, I guess return 0, right? Because I mean, yeah, the sum of nothing is 0, isn't it? Anyway. However, right, if we find, so we should recursively go into, this shit always confuses me. So we want to recursively go, so something like if root dot val equals the low, right? If root dot val equals low, something like that, something like this, then we, well, actually, we want to say if it's not equal to it, right? I mean, because it would be, would we want to say that? If it's not equal to it, keep going down till it's equal to it. When it's equal to it, then we've found it, right? That makes sense. So root.val. So if the current node is not the low value, right? Then we recursively, right? We recursively go into it, feeding in the root dot left, because you can't have the low on the right, right? We feed in the left, we feed in low, and we feed in high. And we just keep going down until, I mean, that will do absolutely nothing. Because, hang on, if the root dot val, my idea is that if this thing is not so, blah, 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 cool. If root dot val does not equal low, then recursively go down the left subtree. Well, the thing is, though, this is the right subtree of this. So that would only, even if what this made sense, it would only go down to 3. Okay, what it needs to do is needs to say like root dot val does not equal low. We need to feed in the left subtree, right? Right. So like, I don't know. Can we do this? Does it make sense? Say something like left equals blah blah blah. You feed in the left, right? Yeah, but that's the problem though. How do I get it to just check this over here while ignoring all this shit? You see what I mean? I understand it intuitively, but I still need to get a better technical grasp of binary tree questions. Actually, no, I like it there. If root.val does not equal low, so let's think about it, right? We have we're going down to this point. This covers the root. So when we get down to below one of these leaf nodes, it returns 0. That's cool, right? But if the root.val does not equal low, then we should recursively add, right? Recursively add. So say value, output equals 0, right? And we say left equals, output plus equals the recursive hang on. If we feed in root dot left, it will recursive, how do you even recursively go down? If root dot val does not equal, actually, maybe it's something like this, and then we say like else output plus equals root dot val. So something like if root dot val is not equal low, recursively go down the left subtree, right? But I mean, we also want to go down the right subtree too, because you get what I'm trying to say here, right? We want to only go down this subtree and then we can start going right and left of both things here. But if I feed in, if I were to say this or right dot right, it will go down this as well. And unless I go down both, does that make sense? So if I said if root dot val doesn't equal low and root dot, actually that would make absolutely no sense. If root dot val doesn't equal low, then range else output plus equals root dot val. If it doesn't equal what we're looking for on the low, then, so in the event that it does equal that, we want to add the root dot val, but only if, right, only if root dot val is less than high. Well, actually, we'll say only if low is less than root dot val. Well, less than equal to. Less than equal to root dot val, and root dot val is less than or equal to high, right? Then we add the value, right? So we have if root dot val doesn't equal low, range sum blah blah blah. I feel like I'm kind of close to an answer here. Hang on. Or right dot right. You get what I'm trying to do, but this won't work because this doesn't make sense, because if you were to go down this, it will go like, or do I make two if statements? Fuck. What's the topic here? It's a depth first search. It's a depth first search. Okay, so I don't need any queues or any extra data. I don't need well, there is of course the recursive stack, which is kind of inherently doing this when I'm doing recursion, so I don't need to like make a queue or anything. I could make my own stack and store things, but I don't really think I do. Hang on, sorry, somebody is. Okay. Alright, I fuck with you. I fuck with you. I fuck with you. You know how it is. You know how it is. Alright, hang on. If root.val does not equal low, right? But cool. See, that tackles it for the low case. I'm off. If root.val does not equal low, but I also want to say something like, actually, can I do a while loop, like while root.val does not equal low, and no, that would not make sense. That would not make sense. Fuck. Hang on. I don't want to spend too long on it. It's been we're 17 minutes into the recording. 13 minutes more. If I can't figure it out, I'll look at the solution. But I really want to concentrate here. If root.val does not equal low, I know this is off. I don't even need to run it. I'll just be wasting memory, CPU time. If low, I know this makes it makes sense. But hang on. If root.val does not equal low, see, saying this right. Saying this doesn't. I don't know. Fuck it. I'm gonna just run it. See what happens. It's probably gonna fail. Oh. Let's see what happens. Fuck it. Let me move this a bit here. I'll put 0. Ugh, of course. I'll put 0. I'll put 0. So it goes down to here, return 0, but it's not doing anything else. That's the problem. So actually, when we get down to here, what are we doing, right? What are we doing? Fuck. Honestly, I'm just gonna look at the solution. Hang on. There's a video. You know, the LeetCode built-in solutions are fucking trash, bro. They are trash. Hang on. I think I did this. I did do this before. What did I submit? I looked at the answer then as well, by the way. If L is less than node.val, if L, wait a minute, that does not make fucking sense. Wait, you're telling me? Oh wait, you're telling me I'm right here? Hang on. If if root dot val is less than low. No, sorry. If low is less than root dot val, then we do the left or something. Fucking hell. We do the left shit, right? Right? If high is obviously less than? No, sorry. If root dot val is less than high, then we go down the right subtree. Wait, what is going on here? And then this is obviously, if the low and high stuff. Maybe this, and then output. Does this make sense? None. Right. Gotta return it. Forgot about that. If low is less than root dot val, right? If the low is less than root dot val, then we go down. Okay. If we're at a value, and if this value, right, just any value, just any chilling value, if low is less than, less than, right? So 7. So we're at 10. We go down the left subtree. This is less than 7, right? Why did we go down the left? Hang on, what happens when I run this? Still 0. The fuck? What did I do? What? What are you talking about? What are you fucking talking about? Does it matter what order this is even in? Does that matter? Does it matter what order this is in? No? No? Yes. Oh, yes. If low upward. Huh. Maybe this should be in the top. Motherfucker! You fucking prick! You fucking dickhead! You absolute twat! It's still not fucking working. You really are just trying to fuck me in the ass, yeah, aren't you, fucking LeetCode? You really just start trying to be a bitch. Man, this fucking shit pisses me off. Literally none of this will be done in the fucking job. But fuck it. The game is the fucking game, ain't it? The game is the fucking game. Ain't that the fucking case, right? Ain't that the fucking case? It should be return output, no? Self dot output. Dot output. 17. Okay, we're getting somewhere. Where the fuck does 17 come from? Wait a minute. If the root dot val is greater than, or okay, so I'm assuming these don't count. Has to be in the range. 10. Okay, shit, that's not the long answer. Hang on. If low is, well, I mean, we add 7 and 15 here, no, right? 7 plus 10, 17 plus 15 is 32. So yeah, if root dot val is greater than or equal to, or less than or equal to the high, then do the output stuff, and then if low is less than root dot val, but wouldn't this be equal to? Well, actually, then it would be like a. Actually, yeah, no, yeah, that makes sense. That makes sense, right? Makes sense. Doesn't make sense. Doesn't do anything actually. Hang on, let me look at what I did. Oh, I didn't return it. What? I just did this. I want to understand what the fuck is going on here. I do. Okay, it's not great. Well, actually, yeah, it would have to. It would have to do that because we're inside of. We're not doing an inner function here. So wait a fucking minute, right? We're feeding in the right. If no.val is less than the right, DVS the right. Oh wait, this is just a normal depth first search. You know, you have your thing here, then you have your recursive whatever. But then why is this not working for me? Why is this given 17? It doesn't. It's not included in the 15 for some reason. Why is that the case? Why is it not included in the 15? Maybe less than or equal to? No, that makes no sense. So yeah, this was a normal depth first search. Normal depth first search, huh? I mean, we're returning self.output here, you know, because let's say we get this to the end and then we return what output is. This makes sense. Yeah, I mean, to be honest, it all makes sense to me. I don't see why it's a problem. Let's look at the submissions. You know what? Let's look at the discuss and see what here. I mean, I think I am getting a bit better. Well, I'll definitely be better than yesterday. I was able to at least think of something. Something here. I wasn't clueless. Actually, I think I uploaded the one yesterday, so I might. Not sure what order I'm going to upload it in, but let's check out the way they wrote it here. See, I don't like when they do this inner function bullshit. I don't like when they do that shit. I just want to stick with one way to do it. I used to do the inner function way as well, but the problem with that is the problem with the inner function shit is that if I were to go to like another language and I don't know, they may probably won't work the same. It's probably just like kind of a Pythonic thing to do. All right, here we go. So I swear to God, this is what I'm doing. Oh wait, he returns stuff the total at the end. Oh, he doesn't even consider it if it's he's not even considering it if it's a node. Interesting. That's how you learn. You'll learn. I have the intuition down, but so interestingly here, he just adds. He doesn't even give a shit. Like, man's just be adding. You know what I mean? I guess so, because at the end he would return. It will get to the end and you will return output anyway, right? What's the saying? No. Oh yeah, shit. If root. So if it's valid, of course. Still 17. Are you a bitch? Are you a bitch? What is going on, mate? What the fuck is going on, my guy? Yeah, you can do less than equal to as well. Ceph plus total. That's not my idea as well. Ceph plus. Well, he actually, you do it at the end. Oh, that actually would make sense why the 15 is not added then. So what? This is a post order traversal or something? Post order is where the node stuff happens at the end, right? Post order. Actually, let me just say post order versus pre-order versus blah blah order and all that goodness. Alrighty then. Alrighty then. There is some pangers out there in London. You know how we do it. You know how we do it. You know how we do it. Ooh. You know how. You think this would get copyrighted if I played this thing for 10 seconds? Literally, I played that for 1 second. I'm actually interested if that would get copyrighted. All right, here we go. I just want to quickly check things out. We got a bottom, we got a post order, pre-order. This is just basically just the position of where the node val is, right? So it's like, yeah. So pre-order is do the node first, then Yeah, do the node first, then do left and right. In order is do left, node, right, and then post order is do left, right, up. Okay, so I mean this technically this should work. I don't know, it should work either way, no? Yeah, actually, if we look at it, it's just a very simple DFS traversal. And we're still getting a fucking 0. Look at me just shying away, man. This is not even the right answer. I know I just looked at the answer, but like I wasn't looking at the whole thing. I'm just trying to see. I'm just gonna understand like what it's doing, right? So we have if root. Obviously, we need to make sure that the root is not null, and then we recursively go to the left. Recursively go to the left. Ah, I see. Because if we're checking each time, we don't need to do this extra check. Oh, I get it. Oh, I get it. And then in this, okay, that makes sense. But then why doesn't he? That's the interesting thing. That's the interesting thing. That's the interesting thing. I think the return. Okay, yeah. So that okay. Now that's making sense. You don't need to do that because all you're doing is basically going left, right, and now you're looking at the node and saying, I get it, because it's a range. You're looking at the left, well, your left, right. So 7, 15, do. So 7, 15, what's the parent? Blah, blah, blah. Still kind of confusing in terms of, I mean, I understand it because I understand how the traversal works, but I don't know, it's still kind of messy, to be honest. It's still kind of messy in my head just a bit. But I definitely understand this better than when I originally did it. When I originally did it, I don't think I actually really understood it. But this is kind of making sense now. Because we have, if you look at the diagram for post order, right? This is a post order traversal because we're going left, then right first, then we're doing our node stuff, right? Our things with the root value. So we're going recursively to the left, right? We're going recursively to the left. So actually, I think it's better if we were to say, post order recursion trace or something like that, just to show how it's traced down. It's kind of, I think I'll watch a video in my spare time. But the idea is when you go down recursively here, you go down all the way till eventually we hit null, right? We hit null on the left side. But when we hit null on the left side, we then go and do the right side and we hit null, right? So we go down all the way here and we hit down all the way here. Now our recursion stack, right? If we look at in fact, yeah, fuck it. Let me just draw the recursion stack, and I think that will help me understand it myself better. Why, what's actually happening internally. So if we draw the recursion stack here, so remember this is a post order, so we're going down the left, right? Then we're going down the right, and then we're going up. But we have these subtrees, so we're going on the left here. Boom, left 5, and then 5 is now in the the recursion stack. Then we go down the right, or does it go all the way down? That's my question. Post order traversal. All right, post order for post order. Post order? What do you mean? I swear to God, post order is left, right, in order. Oh, in order is left. Wait a minute. That's not post order, or did I? Wait a fucking minute. Post order is 1, 2, 3. Why is this saying? Okay, hang on a minute. Hang on a minute, my G. Post order HID. Yeah, whatever the fuck, that shit was wrong. Hey, yeah. So we go down all the way till we hit the end at 3, right? We hit 3, and no, sorry, 5. Or does 5 go into the recursion stack? No, yeah, sorry. This is 3. 3 is in the recursion stack first. Then we go down, we go up right? I won't lie, it's still confusing, but I kind of understand it. And 7 is in the recursion stack. Then 5 is in the recursion stack, right? And then 15 is in the recursion stack. And then 4 is in the recursion stack, right? Then it's returned, and then 10 is in the recursion stack. So we're doing 3, 7. 7's valid. This is now the root. So when we return, when we return, we go backwards, right? So no, we don't. I think it's the other way around. Well, it's going into a stack, so this should actually be on the bottom. No, shouldn't it? I think it should. So we go down to 3 in the stack, then 7, then 7, 5, then 15, then 4, then 10, right? 10 is invalid. So when we return, we now start popping out of it, right? So invalid. 4 is invalid. 15 is okay. 5 is invalid. 7 is okay. Oh no, sorry, 10's okay because 10's in the range, yeah. And 3 is invalid. Is that how the recursion stack for pulse order works? Hang on. Recursion stack for DFS. Recursion stack for DFS. Let's see. What do we got here? What do we got here for the recursion stack? All right. Okay, this looks cool. So, okay, well, what traversal method is this though? Let's see. Well, that's something for me to learn. You know, how's the recursion stack looking? How is the recursion stack looking? Oh, okay, yeah. So this is what traversal is this though? 1, 2, 3, 4. 1, 2, 3, 4. This is what do we got again? We got pre-order. Pre-order is pre-order in order. Pre-order is where the node is first, and then we go down to the left. Okay, so this is a pre-order traversal. So we have the left subtree. These will be popped off. These will be pushed on. All right, so we go down to the bottom. Okay, so we have 1 pushed, 2 is pushed, 3 is pushed. This is already here. 4 is pushed, right? 4 is pushed. So now this is our stack of the left subtree, right? Now we go down to the right subtree, and 5, 6, 7, because that's a pre-order traversal. Node first, left and right. Then, actually, I'm interested. How the fuck is it knowing that not to put 2 twice? Like, yeah, I get it. It's going to go down here, then here. How does it know not to put 2 twice? I won't lie. I need to look over a video again on traversal on this, but okay. I get that. And then, so if this is stacked on, as in 5, 6, 7, how the fucking shit is this printed in this order and not the reverse order? Huh? The printed result of depth first search here we're using pre-order traversal would be 1, 2, 3. Okay, that's the confusing part, my guy. How in the fuck would that be? Okay, I get it. Oh, okay, maybe this looks better. We start with F. Well, this is with a Q, isn't it? Wait, I don't know how in the fuck a stack wouldn't a stack reverse the order? I swear to God. 4 return, 3 return, 2 return, 1 return. How's this the order? What's this nonsense, bro? Huh? Hang on a minute, my guy. Hang on a minute, my G. What's going on here? What's going on here? Okay, we'll check for our first node. Next, we want to check the stack. So how do you solve the problem of traversing the inlet law? Okay, you know what? That's a YouTube video for after this video because that's very confusing. I don't understand internally how that knows not to add that twice, or rather why it's not even in reverse when it's printed. Okay, hang on. If that's in the recursive stack, But these would be popped off. But when are they popped off? Are they popped off instantly or something? Okay, I won't lie. I'm gonna check a video on that real quick after this. We'll do one more question. We'll do one more binary question. Tags. So what the fuck is the difference between a try and a tree? What the fuck? Try versus tree. What the heck is a try? You clearly have clicked this before, so I've clearly asked the question before. A tree is a general structure of recursive nodes. There are many types of trees. Popular ones are binary trees and a balanced tree. A trie is a kind of tree known by many names, including prefix tree, digital search tree, and retrieval tree. What the fuck's a prefix? I've never done this in my life. What the fuck's a digital search tree? A digital search tree. What the fuck is this? A prefix tree. What the fuck's a prefix tree? What the fuck is a digital search tree? What's this binary shit? A digital search tree. Analog radii. Sort of searching. Fixed length. What's it for? IP addressing? Network stuff? Interesting. I think I've done this before in college. Alright, we got a tree. Easy. Status. Solved. Alright, let's pick one more. Same tree. This looks like a decent question. Let me delete all that shit. Alright. So yeah, let's see. Given two binary trees, write a function. What time is it? How long has this been recording going on? 41 minutes. Alright. We'll do this. We'll just spend another 18 minutes on this. I don't want to spend more than an hour on it. Alright. Given two binary trees, write a function to check if they are the same tree or not. Two binary trees are considered the same tree if they're structurally identical and the nodes have the same value. So, the idea here is, of course, I guess we just traverse both at the same time, right? So if, okay, so if P and Q, right? If P and Q, right? We could just say something like return is same tree, the left and the left of each, right? So we can say return is same tree. Return is same tree of the left and the left and the right and the right, right? So basically the left and the right should be equal. And then, I mean, to be honest, any other cases just return false, no? Because, well, no, not necessarily. If we had, actually, no, to me, this looks like it's the answer, no? Name same tree. Oh, oops. False. Let's return a false. Hang on. We're saying the left subtree, the right subtree. Oh, fuck. If P and Q, return the left subtree and the right subtree. No, well, not return it, just like compare the values, right? If they're different than. Well, actually, no, that's not even say that, is it? If the left and the right. If P and Q. If P and Q, then the P left, Q left. Actually, well, the idea would be actually to compare the left and right. So left equals and right equals. It's getting kind of cold. left and the right. Nope. That doesn't seem right at all. That does not seem right at all. Hang on. Let me really think about this. I know, obviously, it's very intuitive to understand. It's just the recursion fucks me up. Hang on. If P and Q, so if P and Q are not null, then compare the left of P and the right of P, right? We're feeding here P dot left and Q dot left. Is that a good idea? Should we be feeding that in? I don't think so. What I was comparing here was the right and the left. Of course, they're going to be different. What I need to do is compare the left of P feeding in Q. No. P. Oh, yes. This would be P dot left, P dot right. And Q dot left and Q dot right, right? False. P dot left, P dot right, and feed it in Q dot left and Q dot right. We're feeding in P dot left and P dot right. Yeah, there must be other scenarios then. What about if not P and Q? I mean, that's just false. Like, I don't understand. Like, I don't see why it would need any more logic here. I'm just saying recursively go return it. What the thing is, the obvious way is to do two traversals. But that isn't it's not very an efficient way. Yeah, I could do like a DFS on both, right? Like a post order, in order, or whatever order. But that's not really efficient, is it? I mean, it will work, but it's not optimal. So I do have a solution that I could write out right now, but it's just not the most optimal. You want to do like, because you're going down the left subtree, you're going down the left subtree of the second tree, then if anything is different, you know to return false. So return self dot if P and Q, so if P and Q are valid, they both have a root node, then if P and Q, it makes sense to me. Like this genuinely makes sense to me, because you're saying give the left and the right. Actually, no, that doesn't make sense. Oh, God damn, tree recursion, bro. You're really just trying to fuck me in the ass. Alright, enough complaining. Let's really start thinking. Let's just start thinking. Mine. Let's get to thinking here. I mean, okay, hang on. We have a scenario where if P and what about, bro? What about if P and Q? If P and Q return is same tree, the left, the right, and the left and the right, right? So if not P and Q, right? So if for some reason that's the case, then You know what? Fuck it. What the fuck did I submit before? What did I say? Because I've done this before. If not P and not Q. If P. Oh shit, the fucking value is what I wasn't comparing. Are you serious? So it's the value. Wait, of course it's the value. The P and Q were fucking. Oh my days, bro. If P dot val does not equal Q dot val. If P and Q. If not P and Q return fall. So then, yeah, that kind of covers everything, doesn't it? And then you could just say, God damn, bro, it's so simple when you see this. Like, I understand the solution instantaneously. I have no problem thinking of understanding the solution, right? Like, you know, we return, these are the scenarios where we return false, makes sense, and then we return this at the end. Go to the left and go to the right. Just trust it works. Still failing. What? If P not Q. If not P and Q. Not P. What? If not P. Oh, sorry. No, that. Wait, how did I only account for the scenario here? If not P or not. Oh. Oh, huge. Oh my god. Oh my days, bro. If not P and not Q. Yeah. Return true. If the value is not the same, then return the subtree. It's still failing. Oh my Jesus Christ. What the fuck? If not P or not Q. If not P or not Q. If not P and not Q. Not P and not Q. Return the left sub. Oh wait, so I was right when I did this first. God damn, man. I was fucking right. Q on left. P. See, I would do a third question, but I really don't think there's a point. You can see that I'm still like it would be nothing but looking at the solution again. It's in my best interest to understand what I just did here. To really understand what I just did is in my best interest. Like I said, yeah, like I keep saying to myself, there's really no way to get better at this other than just trying. If you fuck it up and keep trying it, and the concepts eventually just stick with you. You know, the concepts eventually just stick with you. Motherfucker. What the fucking shit? Just for symmetry. Just for symmetry's sake, return dot self dot P dot left Q dot left. Sorry. P dot left and self dot P dot left Q. Sorry, oops, Q dot right. Alright. Motherfucker. If not P and not Q, return true. If not P or not Q. Like, do you see what I'm saying, right? This is so easy to understand. Literally a second, I understand it. And the fact I couldn't come up with it, unlike like the array questions, means that I still don't understand the recursion part. It still kind of fucks me up. If not P, not Q, so simple. If not P or not Q, return false. Obviously, if either one is empty and the other one isn't, then boom, return false. If they're both empty, then return true. And then obviously check that the fucking values are the same because we're recursively going into it. Because we're passing the left subtrees and right subtrees. God damn, man, it's so simple. And I fucked up. This was the thing we were doing before, wasn't it? This was just a simple pre-order traversal. Pre-order traversal, just doing your thing, you know, checking that the value is greater than or less than this, and how to self-total. I'm just thinking for a second. I mean, yeah, I really do. I understand. I fully understand it. I mean, yeah, just what can I do other than keep just doing it? You know, failing and eventually succeeding. You know, but I understand. I understand. Trick. The principles here is understanding. Is understanding that, of course, the different scenarios, right? Different scenarios. Oh, considering over here, it was understanding the traversal and what needs to happen, right? What needs to happen in in this traversal. I kind of had a better solution here, even though I didn't get it without looking at the solution. But um, okay, makes sense. What can I say? Nothing you could do other than just keep trying shit, you know. Um, yeah. If okay, yeah, I think I'll definitely watch this video back to kind of absorb what I did. But yeah, yeah. I'm not trying to memorize anything, so I don't want to look too hard at it. Yeah, I'm call this a day then. Fuck it.